Hey y'all. In today's video, we're going to learn how to make saturated solutions. And we're going to really focus on two different techniques to making a saturated solution. And we're going to talk about both the laboratory techniques, but also kind of what it means to be a saturated solution. So let's go ahead and get started. Let's get started by remembering that when we create any solution, we're dissolving a solute into a solvent. In our situation, we're mostly going to be dealing with ionic compounds dissolving into water. When an ionic compound dissolves into water, ion dipole forces will pull the solid out of its crystal lattice and will essentially create a sphere of hydration around each ion. The water molecules' oxygen atoms, which are negatively partial charged, will attract to the positive ions from the solid. Meanwhile, the hydrogen, which are partially positive charge, will associate with the anions of the solid. So this process of dissolving is going to create an aqueous solution. And if it's saturated, that aqueous solution is at equilibrium, which means we can add no more solid without it staying solid. It won't dissolve anymore. So when we look at a saturated solution, one of the pieces of evidence that we're going to look for would be solid sitting at the bottom of that container. If we've given it enough time for it to dissolve, if we've stirred it sufficiently, and yet it's still not dissolving, we know that that solution is saturated. When we look at a saturated solution that's at equilibrium, we need to remember that equilibrium means the forward reaction rate and the reverse reaction rate are the same. Any dissolving process, the forward direction is dissolving or dissociation, and the reverse is the solid forming or precipitation. In this case, a saturated solution, the rate of formation of the precipitate is equal to the rate of dissolution of the precipitate. That's why when we add more solid, nothing more dissolves. Adding solid to any equilibrium system doesn't change the equilibrium itself. In the case of solubility, the equilibrium is entirely predicated off of the concentrations of our products, in this case, the ions. There are really two techniques to create a saturated solution. Let's look at the first one. In the first technique, we are simply going to take a solid compound and put it in water. And then we keep putting it in water and keep putting it in water and keep stirring and add more and stir and add more until eventually no more of it can enter the water without staying as a solid. So we know it's saturated in this situation because solid will remain at the bottom. No matter how much more we add, every bit we add will stay as a solid. That's how we know it's a saturated solution. One of the benefits of creating a saturated solution in this way is I know that I've taken a compound with a known stoichiometric ratio and added it into the water. That means my saturated solution will also exist at a known stoichiometric ratio. So in the case of calcium hydroxide, if I make a saturated solution by simply adding calcium hydroxide solid to water, I know that in that solution, the ratio of calcium and hydroxide ions will be 1 to 2. The second way to create a saturated solution isn't exactly trickier, but the math behind it isn't quite as easy. In fact, we're going to cover the math behind this a little bit later in the unit. But right now, you need to understand that creating a saturated solution the second way means you take two compounds, you add them together, and if a precipitate forms, then we know the solution is saturated with the ions of that precipitate. Let's look at a couple of examples of saturated solutions in the real world. In this case, we're going to look at chocolate milk, and we're going to look at probably the person who's sitting next to you's Dunkin' Donuts coffee. So when you look at chocolate milk, sometimes you'll have this like chocolate sludge on the bottom of the milk. What that tells us is that the milk is likely saturated with the components of that sludge. Normally, the sludge is made of chocolate, but oftentimes it's also made of sugar, other things like that. With the Dunk's coffee, especially Dunk's iced coffee, that sugar sludge that you see on the bottom definitely means that the coffee is saturated with sugar and nasty. All right, that wraps up today's video. We learned how to make a saturated solution in two different ways. Remember, way number one is add a solid compound into a solvent until the compound stops dissolving. At that point, we know the solution is saturated with a benefit of a known stoichiometric ratio. The second way to create a saturated solution we talked about was combining two aqueous solutions to create a precipitate. When a precipitate forms, we know the solution is in fact saturated with the ions of that precipitate, although not necessarily at a convenient or known stoichiometric ratio. But like I said, we'll talk about that a little bit later in the unit. This video was written, directed, and produced by Ella Mansour. Thank you so much for watching it. I hope you enjoyed it, and I'll see you in the next one. Features. Key features. Good old boys. By remembering that in any...
And Ryan went